Good morning, Sandite YouTube friends. Um, Working with exponents, and excuse me, before actually beginning that, um, I'd like to talk to you about the importance of reading the instructions that's given to you. You're either going to get instructions one of two ways in the classroom. You're either going to get it out of the book, or you're going to get it from the teacher. And sometimes the teacher may add to what the instructions say in the book. And if that's so, then pay attention and make sure you get that instruction. But so many times yesterday and the day before, I've seen so many examples of my friends working problems out really hard and doing a really good job, except for they may have gone too far because they didn't read the instructions, or maybe they didn't go far enough because they didn't read the directions. So I don't know how well this page focuses in, but I'm just going to read the instructions. And we're dealing with powers and exponents. So, and in this first little section here, there's 6 problems. It says write each product using an exponent. And I'm going to do examples of this on my board to stay true to my YouTube channel that showing examples of math problems that we do here at school. So this first one, write each product using an exponent. So unless the teacher told you to go ahead and solve the problem or find the value, don't go to any more trouble than what's written down. So if I write each product using an exponent, this first one here, if you can read it, there's just 2 6s. So I would put 6 as the big number and a small 2 above it representing the exponent. But right here, this little section, 7 through 12, it's a different instruction. So I have to change gears a little bit. And the first thing that I want to do is read the instructions. Write each power as a product of the same factor, then find the value. Okay? So actually it wants each one of these, 7 through 12, there's going to be 2 different answers to it. Okay? So we're going to write each power as a product of the same factor. Sounds complicated, but it's really not. I'm going to show you how to do it. And then find the value, which means we're going to multiply everything together. This set of problems here has a totally different set of instructions, and always read the instructions first. I think one advice that if I would have given several of my friends a couple days ago is to be sure and read and understand the instructions and what it wants you to do. Right down here, write the prime factorization of each number using exponents. So 2 things that pop out to me: prime factorization, whenever I see those 2 words together, means that they want a factor tree, and we'll do a factor tree. Those are kind of fun to do, and I have other examples of how to do it on other channels. But here's what caught everybody. They wanted your answer using exponents in an exponent form. So let's do some examples of all of these. I think we have time. We're just a little 4 minutes or so. So write each product using an exponent. So problem number 10, or problem number 2, basically what it gives me is 10 times 10 times 10 times 10 equals. Now, reading the instructions, write each product using an exponent. So basically, I'm dealing with a base number of 10. And how many 10s do I have? 1, 2, 3, 4. There's my exponent. Okay? And then I'm finished. Now, if it said find the value, which this one doesn't, then I'd have to multiply all these together. But that's not the case here. Here's another example of doing the same thing. I have 1, 2, 3, 4, 5. 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5. So my base number is 4, and then my exponent being 5. And I'm finished. I don't have to do any more. And to see the expression on some of my friends' faces when I told them that, you didn't have to do all that work in multiplying all this out. This is just a simple thing that they wanted. They just nearly fell out of their chair. So let's do another one. This one has 13 times 13 times 13. Writing the answer as an exponent, write each product using an exponent. My base number is 13. And how many of them? 1, 2, 3 to the third power. 13 to the third power. And I guess what I'm trying to get at is, unless the teacher has specifically told you to go above and beyond what the directions say, just give them what they ask for. Don't go any further, because a lot of times that's where you're going to find yourself making a mistake, or possibly getting the problem wrong because you didn't follow the directions. But if the teacher says to write it as an exponent and find the value, by all means do what the teacher says. Write each power as a product of the same factor. Sounds complicated, but here's what we have as an example. We have 8 to the third power. So if I write that down and I come up with factors of the same product, the numbers they're talking about is 8. The base number 8. And then how many 8s are there? There's 3 of them. Now, that's the first part of the answer. The second part of the answer, it says find the value. So if I'm given a problem like this, usually what I do, I just kind of team up whatever I can. 8 times 8 is 64. And then I'm going to throw in that other 8. So on your scratch paper, if you do 64 times 8, 8 times 4 is 32. I'm going to put down the 2, carry your 3. 8 times 6, 48, 49, 50, 51. So 512. So the answer is going to be twofold. The first part being the 8 times 8 times 8. And then the last part is going to be the 512. So a little more complicated? No. Not really. I followed the directions and did what the directions asked me to do. So let's do one more example. That threw people off a little bit. They were given 2 to the 7th. So if you have the number 2 to the 7th power, one thing I see a lot of people too say, well, okay, well, it's 2 times 7. It's easy. It's 14. Well, we're talking about two different things. This is talking about exponents. There's not actually 2 times 7. There's 7 2's that you have to multiply. So that's the same as saying 2 times 2 times 2 times 2 times 2. How many do I have? 1, 2, 3, 4, 5, 6, 7. Okay, so there's the first part of the answer, and then now I've got to multiply on them together to find the value. And so double up what you can. Looks like we're going to leave out a 2. We'll leave it out for now, but don't forget about it. 2 times 2 is 4. That 2 times 2 is 4. That 2 times 2 is 4. 4 to double up what you can. 4 times 4 is 16. And before we forget about it, let's go ahead and throw in this 2. 4 times 2 is going to be 8. So if we do, and I'm going to squeeze this in right about here, if I do 16 times 8, I should be able to come up with the value. Okay, 8 times 6, 48. I put down the 8, and I carry the 4, 8, 9, 10, 11, 12, 128. So the first part of the answer, I wrote down 7 2s. 2 times 2 times 2 times 2, 7 times. And then the second part of the answer, when I found the value, it's 128. Okay? So it's pretty simple. Just go slow. In this example, remember we had the 2 that was kind of stuck out there by itself, and we ignored it for a little bit, but we included it in the answer. We went back and picked it up. Okay? Let's do a problem using prime factorization. These are the factor trees. And so when you're doing a factor tree, you're dealing with a composite number. Composite meaning that there's several numbers that will go into like 32, for instance. There's examples, 2 times 16, 4 times 8, versus a prime number, which would just have the number in itself. Take 7, for instance. The only thing that's going to go into 7 is 7 and 1. So that would be a prime number. So 32, what do you want it to? Let's use 4 times 8. I like to put the smaller number on the left side, and I'm basically going to get this down until they're all prime numbers. So the 4's not prime yet, so I've got to do one of these little TP looking things. I remember one year a teacher referred to them as Christmas trees. That's fine, it worked. So I need 2 numbers when multiplied together equal 4. Let's use 2 times 2. So the 2's are prime. So I'm going to underline them. Your teacher may want you to circle them. Do something to identify them as being prime. Now, the 8, I'm going to use 2 times 4. That 2 is prime. I'm finished with it. The 4 is going to go 2 times 2. So I basically end up with a bunch of 2's. 1, 2, 3, 4, 5 2's. Okay, but then when I read the instructions, here's what the instructions say. Write the prime factorization of each number. I did that part. But then it says using exponents. So they want your answer in exponent forms. So the exponent, the base number that we're dealing with the number 2. How many 2's do we have? 1, 2, 3, 4, 5. Right there. Now I wrote the number in an exponent form, and that's what they wanted. So getting a little long on this video. So main thing I want you to do, read the instructions, pay really close attention to what the teacher instructs you to do, and I don't think you'll have any problems. As long as you follow those 2 things, I think you'll have it made. Friends, I hope you have a good time playing with these numbers. If you have any problems, you can be sure and contact me, mr.sandite@yahoo.com. Be glad to answer any questions to the best of my ability that I can. I'm just a volunteer, and but I love to help. And Sandite friends, have a good day. We're all safe here at Sector 6. You guys have a good day.